All right. Cool. Share the screen. Hide my awkward self. Let me just pull up the book and I'll pull up the other thing too. But we get to do t-tests, okay? And now if you want to see me do t-tests really slow by hand, so I showed t-tests by hand with Excel and with StatCrunch, all in the video for your final project. So the right video before chapter 9, I do t-test super slow using all the stuff that you need for your final project. Why did I do a t-test? Because they are the most commonly used statistical analysis because they compare means. The hard part about t-test is there's like 3 different kinds, and that's probably your mistake. You have to know which one to use. So there's 3 types of t-tests. So I think that's a great way to start for me talking. Hi, Natalie. I'm glad you're here. You survived the cold? Okay, awesome. I'm going to open 2 things, this and my very messy notebook. Ugh. And I might lean on your smarts because you got all of this homework right. Chapter 9. I hope you felt really smart because I didn't do that well when I did chapter 9. She got them all right. So it is possible to get them all right. You just have to be smarter than Natalie. I don't know how many is over there, but we'll see. So I'm at least just going to try to explain a little bit about t-tests first. And notice that this final project, I do like really in depth by hand a t-test, but do you have to see it all by hand? No. But if you want to watch it for your final project when you have to run it, I do like one data set completely by hand using Excel and StatCrunch, and I got the same answer all 3 times. Shocking. It shocked me when I got it all right. So, all right. So here's chapter 9. But if you want to see it by hand, that's fine. I'm not going to do it by hand because I'm assuming most of you will not. But there are 3 types of t-tests. So I'm gonna write on the board for a minute. So we have these 3 things to keep in mind. And this is where most of the mistakes come, choosing the right test. We have 1 sample. Then we have independent samples. And then we have dependent samples. All right, so these are like the 3 main kinds. A lot of times you'll hear something called like paired samples. Which one is that? You know, like it's so weird. So like these are all different types of t-tests. All right, they're all types of t-tests and they're just for you to compare means. All right. So I'm going to start with the independent samples t-test because this is the one that makes the most sense. Okay. An independent samples t-test is like I've got girls, or sorry, women, females. I never even know what the right terminology is right now. So I don't want to offend anybody. But the mean of females, this is my null hypothesis, is equal to the mean of males. Okay. They're independent samples because usually you can't be a female and a male, right? And then the alternative hypothesis would be that the mean for females is not equal to the mean of males. That's how I know they're independent samples, because you can't be in both groups. Now, a lot of times you won't have the same number of people. I think I gave you feedback on, can't remember, somebody's final project that they wrote in their discussion that like, what do I do if there's not the same amount of people? You're fine for independent samples because you can have different amounts of people in both groups. You're good. Now, the dependent samples, that's okay. This one, you can think about it as like over time, if you want.
But basically you have the same people twice. You can say like, my null hypothesis is the mean, but it's probably just a sample because we can't get everybody. So for the pre-test is equal to the sample mean of post-test. Like you test, you find like somebody's like score on something, you give them treatment, and then you give them the same test again. Are they different samples? No, they're the same people twice. Is that okay? And the alternative hypothesis, usually you'd want the post-test score to be higher, right? This is a one sample, one sample. Is that okay? So when we're talking independent samples, you can really think they're like two separate groups completely. But a dependent sample is what's the same kind of group over and over again. Formulas is like different, right? The formula is gonna be a little different. StatCrunch is gonna be a little different. So you have to know what test to use. The one sample t-test, you can think about it as you have a mean and you want to relate it to the a previous population size, right? So we're just gonna say that our HO is that our sample mean is gonna be equal to like some population score. But we only have one group, and this is like some previously reported value. Is that okay? Does that make sense? We want to compare the mean right now to like everybody that we already have. We have like some mean out there, and we want to say our sample is the same as that. Hi, RA, glad you're here. So is that okay? And the alternative hypothesis for this one would be that our sample mean is different from like the population. You have a question? You don't have a question? Okay, so these are the three big ones, okay? They're the three big ones. So I always think about this as like one group being tested over and over again. I always think about this one as two groups being tested against each other. And this one, we just have one group and we want to relate it to something else. Those are like the three options you kind of have in StatCrunch. And there's more, right? But I don't want to go too crazy into it. But just know that why are t-tests the most commonly used? Because we're talking about averages. So that's why it's so commonly used. Yeah, question. So if we have like a group of people and we're just like, we wanted to see if it's the same as like the population, or if we want to say it's the same as some other mean value we've gotten like from like another group, but we don't actually have the data for them. Right? So we're just really testing one group of data against some number that we already have. That's probably the best way I can think about it. I hope that's good enough. I'm trying to make it as clear as I can, but this chapter, if you watch the video, I messed it up. So we shall see how I do explaining stuff. T-test is the most commonly used one. There's three types because there's so many different ways you can think about means. There's so many ways you can run an experiment, right? So that's why there are so many different kinds. So hopefully that was good. A good start at least.
These were my notes when I was doing it over the summer. And I use pre-test, post-test. Nice. All right, so we're just going to start with these questions. I'm going to do 1 through 5 and 9. I'm going to try my best. We'll see how they go. And if I make any mistakes, I'm going to lean on some big brains in here to help me out, okay? So I'm going to be relying on your smartness to help us through these first group. 4, 6, and 7, you try them as well. But like when I graded the homework, I only looked at those first ones that I really graded. Sound good? All right, so we're going to jump right into it, okay? We're going to jump right into number 1, and we're going to see how it goes. Pearson. All right, we want... Thought I had it open already. That's okay. Hi, Kelly. Glad you're here. How are you feeling? Awesome. I'm going through chapter 9. So this might be a review for you because you did well on chapter 9, right? Cool. I like it. So I'm going to go right to the book. We're going to look at these and we're going to feel really confident about these because they can be tough. At least they were for me. All right. This is 9-1, not what we want. Oh, this was the one that Adrian tried to help you out with. But here we go. We're starting with the review exercises. I believe it's review and cumulative for this one. All right. There's a lot of reading for the first one, right? Is this the ones that we have to do? I think so. All right. Maybe I could get a human to read this giant paragraph. Could I get any help? Thanks, Miles. I appreciate it.
Denomination effect. In the article, the denomination effect by Priya Raghuveer and Joydeep Srivastava, Journal of Consumer Research, volume 36. Researchers reported results from studies conducted to determine whether people have different spending characteristics when they have larger bills, such as a $20 bill, instead of smaller bills, such as $21 bills. In one trial, 89 undergraduate business students from 2 different colleges were randomly assigned to two different groups. In the dollar bill group, 46 subjects were given dollar bills. The quarter group consisted of 43 subjects given quarters. All subjects in both groups were given a choice of keeping the money or buying gum or mint. The article includes the claim that money in a large denomination is less likely to be spent relative to an equivalent amount in smaller denominations. Test that claim using a 0.45 significance level with following sample data from the study.
That was so well read. And I didn't really, no matter what data they give me, I always check the journal. So I checked this journal article, and Journal of Consumer Research is a Q1 journal. So highly respected, highly reputable journal out of Oxford. So we know we at least have a good journal. So first of all, do we think that this is the same group? Are these dependent samples, independent samples, or just one sample? What do you think we're using here? They're independent samples, right? We have the group with the $1 bill, and we have the group given the 4 quarters. So that's giving us the idea that we have what? 2 separate groups, and you see how our ends are different here. We have 2 different ends. So we have different group sizes, but that's okay. So I'm going to just try this out of StatCrunch, and I'll see if I get the right answer, right? Oops. All right, so let me open my StatCrunch. StatCrunch website. So we know we're doing a t-test because we're dealing with what? We're dealing with means, right? Oh, it's percentages, yes. But I still think this would be a t-test for us. But we'll see. We'll see how it goes. I could totally be wrong. Feel we have a 2 sample with a summary. Yeah, so you're right. So this is going to be a what? We're doing a proportion. So we're going to go to stat, proportion stat. But now it's not 1 sample anymore. We have 2 samples. Because they don't give us the mean, we know we're doing a proportion statistic. So 2 samples. Do we have the data? No, we just have the summary. So we're going to go to the summary. So all we have to do right now is just put in the information that was given to us, and hopefully we can come out with the right answer. So we have, so my observations. So this is my total. For my first group, it's 46. And how many people spent the money? 12. Because that's our success, right? Do we have more than 5 of each? Yes, right? So like we have more than 5 yes, 5 no. We've got a big enough people. They said it was randomly decided between colleges, so I think I can use this one. This is 43 and this is 27. All right, and we want to figure this out. We're using a 0.05 for critical value. Test the claim using a 0.05 significant level. So so here's your claim. Money in large denominations is less likely to be spent than money in bigger denominations. So this would be 0 for our null hypothesis. This is saying that they're both the same. Now, is this going to be greater or less than 0? Where our claim is that the money in the big one will be what? Less people are going to spend it, right? So if we did it this way, then this one should have a bigger amount. So that's why this one should be a greater than 0. Was that okay? Why it's greater than? Does that make sense to everybody?
Greater than or less than?
Well, we made this one group 1, right? The 12 out of 46. And then we have this one is 27 out of 40. Well, this one we're claiming we'll spend more of it. So, oh yeah, it's going to be a negative number. So it's going to go the other way.
No, but then that's the right way, because 0 should be greater than the number.
0 should be greater than the number. P minus 1 greater than 0. Yes, that does make sense. P1 minus P2 should give us a negative number. And this is going to be less than 0. So confusing, right? So we have to know based on our claim which way we're going to make this arrow. Because we want a negative number, right? Because this subtracted from this should be less than 0. This is what we're trying to prove. It is less than 0. This is correct. That was a lot right there, right? All of this is correct. All my buttons should be pushed correctly. I have this to find the critical value and I click compute. That's the hardest part. What? First hard part is picking the right idea, right? We're talking percentages. We got to use the proportion stats. Second hardest part is, do they want a confidence interval or are they testing the claim for a hypothesis? This is what they're testing, so we need this. We also have to figure out what this is. If they didn't have a claim and they said it would just be different, this would be not equal and it would be two-tailed. But our claim is that these people are going to spend more of their money because they have smaller bills. All right, any question about how I set that up? Because I got lost a little bit. Good thing I'm relying on your very large brains in here to help me out. So I'm clicking compute. Significant. We win. We won the prize. How do I know it's significant? There's 2 places to look. First place to look. Does our z-stat, this is our test statistic, is it smaller than our critical z? Yes. This is smaller than our critical z, which means it's further away from what's normal information. So this makes it significantly different. Other place you can look, if you hate seeing if it's bigger or smaller, you just look for your p-value. Our alpha was what? 0.05. Is this smaller than 0.05? Yes. The null is low, it must go. I'm pretty sure that's what the book said. Their corny line, right? So my p-value is less than 0.05. So what does we do? Reject the null hypothesis. So we are confident that guess what? People with smaller bills are more frivolous with their money. And you can write the right statement if you want. If you want to write the correct statement, because the book always, I mean, the online tests and stuff always want you to be perfectly right. We are 95% sure that this is not due to chance, that people in group 2 will spend more of their money than group 1. Is that okay? Is that clear? I'm going to rely on you, Natalie. Did I mess that one up? Okay, cool. Because I know you got them all right for these. Question, yes.
P1 will divide by 4.
P what?
P1 12 by 46.
12 by 46. Oh, what I did in the top? 12 and 46. Yeah, is that what you're asking? What's your question? I'm sorry.
What's P1?
Oh, what are they? Okay, so that's such an easier question. I was curious. So P1 is the probability of people spending money from group one. P2 is the probability of people spending money given 4 quarters. Is that okay? Okay.
Is it P1 is 12 by 40?
You could think about it as 12 divided by 46. Yeah, as that percentage. Sure, that works. But that's just the sample percentage. That's just what we got in that snapshot. We have to run the statistics to be sure that that is, in fact, smaller than this. Because you can see that this is smaller than this side, right? But we have to be statistically significantly sure that it is smaller. Did that answer it? Okay, cool. We feel good? All right, guess what? We made it to number 2. I'm excited. All right, Alejandro, it's much shorter. Can I trust you to read this? Okay.
The confidence interval that could be used to test training exercise 1. What feature of a confidence interval leads to the same conclusion from exercise 1?
So we have to go from hypothesis testing to confidence interval, right? So all I have to do, it's all the same data, right? All the same tests. I just have to change it from one to the other. Now, because, what are we, 5% sure? I'm going to do a 95% confidence interval. Does that sound fair? Does that make sense? If we're using a 5% alpha, to me, that means we are 95% sure. And please let me know if this doesn't make sense to you, but this is what I would consider to do for this situation. I would take this data, I would go to options, edit, and I would change this to a 95% confidence interval. That's what I would do. And I click compute. So this is what I got. I got a lower limit of negative 0.56 and an upper limit of negative 0.17. Now, I'm not sure if that's correct. Let's see what I actually got when I did it before. I did that 95%. All right, so I was wrong. So apparently there's a table, which is great, and I didn't see it. So when you have a 5% alpha, you have a 90% confidence interval. Why is that the case? There is a table in the book that says it to be so. I think it's probably because we're a one-tail test or something, but I'm not even going to argue with it. I'm just going to tell myself that 5% alpha is a 90% confidence interval. So this is wrong. So we have to go to options, edit, and make this 90%. I'm human, make mistakes. I just did it again. It happens. You'd think 5% would go to 95%. Not today. 5% goes to 90%. All right, so this is the answer to the second one. It's really between negative 0.52 and negative 0.20. So this is your lower and upper limit for this. But how does that give us the same answer? Anybody have any idea how that gives us the same answer that we got? So we have this answer, right? 90% confident that our scores are going to go between negative 0.52 and negative 0.20. If I go to options, edit, and we go back to what we had before, right? We've got these values, which are a little bit different. What am I thinking?
how does this 90% shorts between these two values for the lower and upper limit give us the same piece? What are we thinking? Anybody have any idea how these are the same?
What would I do? I'd probably go back to the original two data, divide them and see our percentages and see if the difference falls between this range 5.2 and 0.21. That's what I think they want for number 2. We can look it up in the back of the book. You want to know see what they said? I think we should see what they said. I hope we're all cool with that. So I'm going to go to the back of the book and just pull it up because I have that power. So I'm not really sure why, but my guess is that they divided the percentages to see that it falls between, but I don't know. And because this is an all review, we get to check all of them. It doesn't just have to be odd problems. So we're looking at chapter 9 review. Eight 5, 8 review. And we want that's 9.2, 9.4. Quick quiz. Here we go. Number 9 review. All right, so here it is. The first one, 0.002, reject the null. There's sufficient evidence to support the claim that money in a large denomination is less likely to be spent relative to an equivalent amount in small denominations. Correct. Number 2, 90% confidence interval. We got these values. Okay, so what is their reason? So the confidence interval limits do not contain 0. So it appears that there's a significant difference between the two proportions. Because it consists of negative values only, it appears that P1 is less than P2, so that the money in large denominations is less likely to be spent on a relative amount in small denominations. That makes a ton of sense. Our confidence interval does not have 0 and is the negative that we're looking for in the alternative hypothesis. Does that make sense? So we had these two. This was our HO, right? That was our null, right? That it was going to be 0. We got two negative numbers, not 0. Our HA was this. Less than 0, right? And both of our confidence intervals are negative numbers. That's why it's the same exact answer as we got for the first one. They're both able to reject the null. We can never say we're accepting the alternative, but this lets us know that yes, we are rejecting. Yeah. These two values? Yeah, I can show you. So I got these two values when I was in StatCrunch, and I'll pull that up. I'm sure I'll need it again, right? We'll check them all because I really want to make sure the reasoning is on point. So when I went to options, edit, and apparently in the book, if it's 0.05 for alpha, you have to use a 90% confidence interval, and you just look at these two values. There's my lower limit, negative 0.52. There's my upper limit, negative 0.21. All right, we feeling okay? Is it helpful? A little bit? I'm trying my best. We made it to number 3. Who's excited? I guess nobody, but I'm cool with that. All right, can I get another victim to read number 3? Thanks, Natalie.
Using 0.05 I think earlier from the population.
Thank you so much. So My mistake when I did this on the computer, because I watched myself before this and I saw my mistakes and I felt really dumb. My mistake was picking the wrong t-test. So Natalie just read it. What does it mean? So we did this forecast, and these are the actual temperatures that happened that day. Are we thinking this is one sample, independent, or dependent? Why do you think independent? Because they're different days? Okay, why do you think dependent?
Because 5 days earlier, that's like the before, and then the actual like after, like it passes.
I agreed with Tenzin when I did it because I was like, oh, this is just a thought what it would be, you know? Like to me, these are just somebody's ideas about it. I'm not going to link them to the actual. To me, I thought there were different samples. But the book went with Miles because this is what they thought Tuesday would be, and this is what Tuesday was. This is what they thought Wednesday would be. This is what Wednesday was. This is what they thought Thursday would be. This is what Thursday was. So this is a dependent samples t-test. I made the same mistake you did. It happens, right? And the only reason why I know it was wrong because I looked in the back of the book and I got angry. So I was like, there's no way they're the same day because it was somebody predicting the day. So that's why they're saying it's dependent. We're going to use a dependent samples t-test. So we're going to go to StatCrunch. Oh, where's my StatCrunch? All right, so we're going to go to StatCrunch. The first thing I have to do is put in the data, though. You see how they gave me data? So I got to put them in. So here we go. We're going actual and then the prediction of our temperature. So I got to type these in. I got 80. Oh, wait, sorry. 80 actual, 77, 81, 85, 73, 73. 80, 72. What's left? I'm so blind. Where's my mouse? All right. 83 and 81. All right. So that's the first one. Now my predictions were 80, right on the money. 80, 79, 80, 79, 82, 76. I'm so blind. 73, 77, 83. All right. Is that okay? Just type them in. I'll make it bigger. Oh, yeah. I forgot I can zoom in like Excel. I can't make it bigger. I'm a liar. Is that okay so far? So I'm going to go to stat. We're going, why we're using means? Because it says mean. Where is it? Right here. We want to know about means. So we're doing a t-test. And we're doing a not a two sample, a paired. So they call the dependent one paired. Sorry about that. They call them paired. My fault. In Excel, I'm pretty sure it's still called dependent samples. All right. So the first one was I guess it doesn't matter because it's paired, right? Yeah, I'm going to go actual first. I'm going to go I already have the column. Oh, so sample 2 is prediction. We don't need to group it. All right. So my hypothesis test would be, my null would be there's not a difference. And now for this one, we have to check the claim. Is it one-tailed or two-tailed? Do they think it's going to be higher? Do they think it's going to be lower? Or is the claim just that there's difference, right? So we have to go back here to check. All right, so listed below our actual temperature, blah, blah, blah. 0.05 difference between the actual temperature. So they don't say which way, right? Do they say one's higher than the other? No. So this means we're still two-tailed. Is that okay? We feel good? So I'm just going to go to compute. I like the critical value of 0.05. Compute. There's no difference. There's two places we can look to see how wrong we were, right? Is our statistic, see how this is a positive one, so it has to be bigger than it. If this was negative, we'd have to be smaller than it. Because it's positive, this number isn't bigger than that, not significant.
Is this less than 0.05? No, not significant. So what do? We accept the null hypothesis. Well, we don't say accept, we fail to reject the null hypothesis. We're saying that we can't prove that there's any difference. Okay?
Questions about this one? Well, we can look what the book says now that I have it up nice and fancy. So what does the book say?
So here's our HO. 0, not equal to. There's our test statistic. There's our p-value. Notice, oh, they used this one, right? Critical value is this, fail to reject the null. There is not significant evidence to warrant a rejection of the claim. See how they're not saying they're accepting the null? We could only reject the null or fail to reject the null. I know the wording is so important, but that's what they want to see. So you could either fail to reject the null or reject the null. So there does not appear to be a difference between actual temperatures and temperatures 5 days earlier.
Is that okay? Feel good? Questions? Am I making it clearer? All right, we'll see. All right, we're moving on. We're up to number 4. Okay, let's see number 4. Maybe a new human wants to read it, a new person. Don't all volunteer at once. You already helped, Miles. Yeah, go for it. Thank you. Bless you. Before, I would say no, right? Because it wasn't significantly, actually, no, it wasn't significantly different. No, they were doing a bad job. They were doing a bad job. So let's see what happens. So, I might as well show you my mistake first before we look at it. So for number 3, oh, I got it right. That's nice. For number 4. All right, so why'd I use 95% for number 4? Well, anybody have any idea why I went with 95%?
Because it says 0.05, but then you didn't realize there's a thing.
Maybe. We'll see. I'm gonna look at there's like a little table in here. I know I pulled it up in I'm gonna find the little table because I know I have it in one of the pictures for your modules, just to make sure I have it right here. But I think because it's two-tailed, it went from like down to 90 and then back up to 95. Because it was 5%, it was 90, but because it was two-tailed, I had to go up to 95. I'm pretty sure that's the reason why. But I'm just trying to remember it all. So for the review, I think I put it right in there for you. Oh, it's in the announcements for the review. Sorry. Yeah, cool. So here we go. So this table will help you a ton. Okay, that's why I put it right where the video is. So we were 0.05. Before it was a one-tail test, that's why it was 90%. Now we're at now we have a two-tailed test at 0.05. That's why it's 95%. Make sense? It's right in here for you. You can take a picture of it if you want, but this was the table I kept not knowing where it was, and that was my main mistake while I was doing all of this, because I was like, I just assumed 5%, 95%, but really matters if it's one-tailed or two-tailed and your significant level for the hypothesis testing. I know that's annoying, but here's your table, and this is why we're using that. Yeah. So for two-tailed, you subtract the significance level,
And then for one-tailed, you can just think it has to be doubled. 10% is 20%, 5% is 10%, 1% is 2%. That's how it works. So for two-tailed, you have to double it. For this one, you just subtract. Because we're doing a two-tailed test right now, and it's 0.05, that's why it's 95%. Feel good? Cool. All right, so here we go. All I have to do is go to options, edit, change it to this, 95%, click compute. You already have everything there, and there's your answer. So we have, it's between -3 to +3, right? You see that? 0 falls in there, right? That is why we fail to reject the null. That is why. Does that mean they're doing a good job if they're the same? But we're failing to reject the null. I don't know. I always get confused trying to say it all
They're
once.
doing a good job because there's not significant difference.
Yes, those are the words that were up here and did not come out of my mouth. Because the zeros here, we can claim that yes, they're doing a good job, that their predictions are close enough to the actual. Is that okay? Good. Slightly clearer. The weirdest thing ever. We can see what the book says, but it should say that. Yeah, sweet. First step is correct. We have a 95% confidence interval. We're between here and here. Because the confidence interval includes 0, we fail to reject the null. There's not significant evidence to warrant rejection of the claim. There's not a difference between actual and the forecast. They are doing a good job. Feel good? Okay. All right. Well, we made it to 4. Let's do another one, right? Let's do another one. Let me put questions. All right. I will be quiet. Here we go. We're going to number 5. Okay, we have a new problem. I'm excited. So here's number 5. And Kelly, would you mind reading 5 for us? That was so well read. What stood out to me? First of all, we're talking one tail. We're saying one of them is greater, right? So we already know we're one tail. We have our significance level. Do we think it's one sample, independent sample, or dependent, or which is paired? Which one are we going with for this situation? We got to pick the right test.
It's like 2 different groups of people.
Exactly. Does that make sense? It's not the same people going through 2 different treatments, right? It's like 2 different treatment programs that we want to see which one's more effective. Is that okay? That's why we're picking independent samples. All right, so the whole idea is we really have to know which one to pick. My mistake kept being which one is the right way to go, but this one's independent. And I looked this one up. I promise the Journal of American Medical Association is a very good, well-respected journal. So we can follow their results. So all we have to do right now is just plug it in because they're giving us what? They're giving us the summary, right? So we have the summary. So I'm just going to go to statistic, T-stat, to sample with summary. Are you sure?
Yeah, we have the ones that weren't smoking in the total. You don't have any means.
51 smoking, 199, 30 smoking. Do I have any means? I don't have any means. So this is another probability. Good call.
I almost picked the wrong test. Sure, when I clicked on it and I saw I had no means there, I would have got there too. I mean, I hope I would have figured it out. So we're talking 2 sample with summary. Okay. So the first one was sustained care. We got 51 successes, right? Because we want to say no longer smoking is the success, right? I'm hopeful that's what we want, over 198. And then we have standard care, which is 30 out of 199. Our P1 minus P2 is 0, right? That'd be no difference. And which one do we want to say is better? We want to say that the first one is better. We want to say that this one's going to have a higher rate. So this means, is this going to be greater or less than? Why are you going greater?
Because P1 minus P2, we want P1 to be greater, so.
A positive number. Yeah. So this, to me, the hardest part, pick the right test, put in the right information, make sure these are in the right direction. We can get that. Should be good. Okay. I'm going to show a critical value, but now my critical value is not going to be at 0.05. It's going to be at 0.01 because that's my significance level. And when I look at my p-value, it's got to be less than this 0.01 for it to be significant. Okay. So let's see if this is actually better. Let's see if sample one is indeed statistically significantly better. So anybody lost? All right, I'm clicking compute. It is better. Look at that. There's 2 places to look. Our z-stat is bigger than our critical z. You see that? 2.3, 2.6. We're good. This is less than 0.01. We're good. Feel confident? Are we confident now? All right. I'm going to do one more, right? There's one more of these. We're doing number 9. Okay, cool. Nice. The last one of this group. Oh God, it's so long. And there's data. Great. And I know I did this already, but still, like when you look at them, like sometimes these problems look so crazy to me. So here's the last one we're going to cover. SB, I don't think you've read yet, right? Okay, you've been hiding right in front of me. Do you mind reading number 9?
Review what's on email, personnel 11988. From data set 2, answer 119. And wasted competencies and selected views on email, personnel 1912. From data set 3, answer 2, 2012. Use a 0.05 significance level to test the claim. Are in the population within 0 milligrams, indicating that there is no change. What is seriously wrong with this question?
They're different people, right? Because they want us to do a paired.
Yeah, but there's still army people from the army, right? I feel like the book is kind of throwing off.
I think what's wrong with this is because they want us to do a paired thing like over time, but I promise you the people from 1988 are no longer in the army in 2012.
Yeah.
These are different humans. So even though they want us to do a paired, a dependent t-test, we can't. We should be doing a what? An independent samples t-test. But they said that they want to do a paired data. That's bad. They're not paired data, they're independent samples data. So I think that's the problem with this, right? That makes sense? We shouldn't be doing a paired samples t-test, we should be doing an independent samples t-test here. You can't pair these up. That's what I
You're
think.
kind of like just considering like over time, does the average of the military waste go up or down?
To me, that's an independent samples t-test in my brain. But we can look at it. We're gonna run it. We'll see what the book says at the end. So I'm gonna run a paired samples t-test, even though I shouldn't be. and we'll see what happens, right? All right, so here we go. So I'm gonna put the guys from the 80s and the guys from 2012, and we're gonna see what happened to their waist size. Millimeters and waist size too, not centimeters. This is weird. 852. It would make so much more sense if it was like actual like 35, 31, you know what I mean? Like a pant size. 825. Well, we'll see what the right answer is at the end because I can't even remember this one. 903, 874, 935. Cool. Boom, boom. Boom, boom. The other one, we got skinnier? No way. We definitely got fatter. 9. It should be. 938, 933, 986, 946, 748, 934, and 802. All right, so I'm gonna go to stat, T-stat. They're telling me this is paired. I disagree with it. 1988, 2012. And it's just this one. It's a two-tailed test. And we're using a 0.05 significant level. So let's see what we get. All right. I got non-significant difference between them. I guess they're close enough. So this is what I think the answer is. I don't really remember 9, so I'm going to look it up. So let's see what the right answer is for number 9. Oh, I got to go over here. Here's number 9. The waist circumferences from 1988 are measured from 8 guys from different males. So the data are not paired or matched in any meaningful way. The stated claim makes no sense for these two independent samples. Here are the results that would be obtained by blindly following the instructions. So was it independent samples? T-test? Like we should have done? Our P
It is, but it still wants you to do it in pair.
Oh, okay. Well, whatever. Okay, so we should have run a what? An independent samples t-test. This is the right answer. We're going to change it. We'll actually see if there's a difference. Let's run it independent anyway. Like this is the answer that they want. It's wrong because they're not matched in any meaningful way. So let's actually do it the right way to see if there was a change. So let's go to stat, t-stat, to sample with data. Let's see if there was an actual meaningful change at the 0.05 level. Still no meaningful change, but it's a little bit different, right? Notice that the p-value is a little different. This should have been our answers. Oh, that's the one you got? Yeah, that should have been the answer. That is correct. The one before it is, but this is to me, this is what you should have done. You get what I'm saying? Because it is independent. I know it's tricky. I just look at when I did it right the one way. So, but yeah.
Did we fix it or?
If you don't fix it, that's not a big deal. You did fine on it. I barely took off any points. I feel like I don't remember. I graded so much this weekend. But yeah, that's what they wanted. They wanted paired, but you were right to make it independent. You were smarter than the book trying to trip you up. You should take solace in that fact. All right, so we have 20 minutes, which is nice, right? 20 minutes left. What would you like to do? I just really wanted to go over those so we all felt okay about them because I struggled when I made the video. Is there anything you want to see? Do you want to see the other ones? Do you want us to go through the last 3 problems from the cumulative review? What would you like to see? Yeah, let's do them. Cool. Yeah, let's do. We can do whatever you want. You guys ready? I will continue to go and we'll check them in the back of the book. That's why I wanted to pull it up. See, I have the cumulative review right here. So let's make sure we get them all right.
Pearson.
Oh, okay. So can everybody try those? I'll do the Pearson ones. Is that okay? We'll do some of the Pearson. You want to do review 9? The 9 review, 7 or 8? Which one would you like to do? It doesn't matter for me. Let's do 9. Let's jump into chapter 9 review. If you want to see, if you need help with these, let me know, but the cumulative review ones look the same. So let's jump into the Pearson review. I know I messed up one of those a bunch, so let's start from the beginning and knock them out. And I might make another video for just chapter 9 review. I might sit there for like an hour and just do them all. We'll see. We'll see how much wherewithal I have. So I'm going to modules. I'm going to go to the review. Was there a specific one you want to start with, or should I just start from the beginning? All right, so here's chapter 9 review. Notice I pushed back all the dates to try to make your life less scary. Which one would you like to see? We're going to go to number 3. Works for me. I'll go to 4. Here's number 4. All right, cool. Ashley, I don't think you've read. Can you read this first one on top? What does it say? Oh, okay, sorry. Oh, but yours might be different than mine on the screen. Yeah. Can you see that? Insecticide.
Among 299 infants not using children, a 0.01 level successive a malaria lower for infants using children.
Yeah, so like you can imagine babies with these little nets over where they are they actually getting malaria? Crazy, right? What is weird and like kind of morbid, like kind of study, right? Like, are these babies going to get this serious disease by putting nets over their cribs? Kind of nuts. All right, so our null would be that they're going to be equal to each other. So we know A is out, and we know C, F are out. So we're just looking at B, D, or E. The claim was, will it reduce malaria, right? So which one is it? Is it going to be it can't be B. So it's not two-tailed, it's one-tailed. So is it going to be P1 is less than P2 or P1 is greater than P2? What do we think? Is it D or E? We want to make sure less infants get the malaria. I'm going D, right? Does that make sense? Let's see if it's right. Nice work. All right. Step 1, right? Step 2 is get the test statistic. I'm not going to do this by hand. You know why? I'm tired. It's late. I'm going to let StatCrunch be my brain. We okay with that? So here we go. So I'm going to go right to, got to move this here. And I'm going to go to stat. We don't have means here. So this is a proportion stat, okay? Because it has P's here, it should just jump out. Proportion stat to sample with summary. Is that okay? All right. So my successes for sample 1 are 12 out of 345. And my successes is 34 out of, what is that, 299? Cool. And we want this to be what? Since we want this less than, P minus 2 has to be what? Less than 0. Is that okay? Now, all I have to do is click this because they want the test statistic, but I always want the critical value anyway. I'm going 0.01. We good? Click compute. My test statistic is what? The Z statistic. Not the critical Z, the Z. We want 2 decimal places, which is negative 3.88. Here we go. Negative 3.88. Let's see if that's correct. I hope so. Nice work. All right, let's keep it going. It feels so good when you get them right, you know? All right, so here we go. What's my p-value? 0. It's less than 0.0001. You better use those bed nets when you have babies. Don't let them get malaria. So I'm putting 0. Fantastic. All right, here's the hardest part. Since the p-value is less than the significant level A, we reject the null hypothesis. Is that okay? Am I going too fast? All right. Now let infants using bed nets sample 1 and let the infants not using bed nets be sample 2. We have to make the confidence interval. Okay, so this is where we have to remember before. Two-tailed, one-tailed, we're using 0.01. This is a one-tailed or a two-tailed? It's a one-tailed test. So all you have to do is make it what? Edit and make it 99. Is that okay? Remember that table I showed? As long as it's one-tailed, you just subtract it from 100. Do I have it here for us? I might have gotten rid of the table. I'm sorry. But that's all you have to do. If I'm wrong, I'll pull up the table again. Double? I don't know. Should I pull it up again? I should pull it up again, right? Why not? Safe? I hate when I get them wrong, so. That's why I took a picture of, I screenshotted the table, right? All right, so we're doing you're right. One-tailed at 0.01 is not 99. SB was correct. It is. Thank you, SB. I would have gotten it wrong, right? I would have gotten it wrong. You're so smart. All right, so so let's put it in and get the right answer. So we know our lower limit is what? -1, how many decimals? 3. So it's -1.27, -0.127, and the other one's going to be -0.030. Check answer. We got it. Thanks to SB. Not thanks to me. Oh, more? Okay, so here we go. So what is the conclusion of the confidence? Since the confidence interval does not contain 0, there appears to be difference in the proportions because it doesn't contain 0. If it did contain 0, there would not be a difference. Check the answer. Oh, there's still more. You picked a great problem. There's like 52 parts. We'll do as many of these as we want. We still have 10 minutes here. Okay, so according to the hypothesis test, you ready? Wait, first, did anybody get lost on all of these steps? Nobody's lost? Okay, I would have gotten lost. All right, there is sufficient evidence to do what? To support the claim that malaria is lower using bed nets. So bed nets appear to be effective. According to the confidence interval, there is sufficient evidence to support the claim that it's lower for infants using bed nets, so the bed nets appear to be effective. It's the same thing. Sufficient appear, sufficient appear. Put those nets over those children, keep them safe. And we got it right. Cool. Is that good? All right. Were there any other scary ones? So otherwise I have to start at number 1. Anybody else was trying this or no? All right. All right, Tezin, pick your favorite number. You got between 1 and 15. All right. Why I'm not surprised. Looks so hard. All right, so here we go. I need wait, did everybody read? I think so, right? Alejandro, you get to go again. Read the top.
In popular theory is that selectional candidates have an advantage if they are taller than their banging components.
Okay.
Heights, centimeters. Randomly selected residents along with heights of their main opponents. Two parts A and B.
Cool. So we got our president and we got their opponent. Were they taller? Are we really that shallow of a people? Probably, right? So I'm going to click open in StatCrunch, right? So I don't actually have to retype in the data. Isn't that nice? Okay. So we're using a 0.01 significance level for the heights of presidents and their main opponents. The differences have a mean greater than 0. In this example, mean D is the mean value of differences of all of it. Okay. So to me, the mean would be equal to 0. The difference would be 0 centimeters, right? That would be the null, that they weren't actually taller. And now this, the difference would be greater than or less than 0. Because we're saying that the president is taller. So president minus opponent would be greater than 0. Was that okay? I think I did that right. Well, we're about to find out. Okay. Well, did that make sense? All right, so let's do B. Okay, so I have to do the T statistic. So here we go. Now, what do we think this is? We have means here, right? I have data. So what are we doing? Do we think this is a dependent or independent sample? We should get this right. Independent, dependent. Who thinks they know? I'd love a hand. Yeah? Exactly. Why? Yeah, it's not the same guy twice. And it's not like, to me, I think that they're different. We'll find out in a second if I'm wrong. But to me, I do not think these are fully paired. Could it be? Who knows? But I think these are independent. But we're about to find out, right? I could be wrong, but I'm doing a 2-sample with data. 2-sample with data. The first one is my president. The second one is my opponent. And we're going to say that this is greater than 0. And our critical value is 0.01. Clicking compute. And my T statistic, let's see if this is right. What do we want? 2 decimals? 0.22. I'm hopeful that it's correct, but we're about to find out. It's incorrect. So maybe it was paired. Maybe it was paired. I wouldn't like it if it was paired, but I'm going to try it again with paired data. Unless I made another mistake here. I don't think it's paired. Everything else is correct. Did I use the wrong significance level? I don't know. So if I pair it, it's now 0.25. I hope they give me a reason why this is paired. Okay. I guess because they're matched up 1 by 1, that they're at the same exact election cycle. You know, I guess I really have to look at the definitions where they think independent and dependent. Maybe independent's like a completely separate thing happening, but they're the same election, so it's one exactly against the other. That's why they think it's paired. I still don't like it, but this is a paired data. I'm human. I make these mistakes, but I would look really, that's why the hardest part is picking the right test. All right, let's see what the next thing says. Our p-value is 3 decimals. All right, so 0.811. Incorrect. I don't know how I have the right test statistic and the wrong p-value. But I guess I'll look at a example since I got that one wrong. The first requirement is that the sample is dependent because they are matched pairs. Okay, I'll take your word for it. Next is it's a simple random sample, blah, blah, blah. Check the requirement that the pairs is larger than 30. It's not. So we had to check to make sure it was normal. Did we do that? Nope. So you always have to make sure you have a normal population. Okay. So we got that right. That was how you got the test statistic. The p-value is probability of getting the null. Read the p-value from the same output technology as the test statistic. I thought that's what I did. Did I type in anything wrong? Height. Oh, yeah. So when I redid it, guess what I forgot to do? I forgot to change this. I forgot to click this button. That's why my p-value was off. Feeling dumb over here? That's me. So it had to be greater than 0. When I changed the test, I didn't change the hypothesis because it automatically sets it to equal and not equal to. And I'm also going to put these in. What am I going to put in? A histogram. Why? A histogram, a dot plot, and a box plot. Why am I going to do that? Because I forgot to do it before. It doesn't look that normal, does it? Right? Doesn't look that normal to me. So we probably should be using this data anyway. But that's okay. At least we get the right answer now. It is not 811. It is 0.406.
Doesn't technically have a normal distribution?
Yeah, but they said we should be checking our specific data. Well, no, it does, but we're just looking between two people. So, all right. Since the p-value is greater than the significance level, we fail to reject the null. There is not sufficient evidence to reduce it. And now the confidence interval. All right, so one last part for this. So our confidence interval, I'm going to look right back at our chart. We have a one-tailed test at the, what is it? At the 0.01 level. One-tailed 0.01 level, we have to be what? 98%. I probably would have gotten it wrong. Thankfully, SB had us pull up the chart again, so we're good. So this is the answer for the last one. We are between, see how 0's in the middle? We have from -12 to 14. That's why it's not significant. All right, so we're between one decimal place, -12.4 and 14.4. Well done. Since the confidence contains 0, fail to reject the null. And that's the end of this one. All right, we only have 2 minutes left. I'm not going to start another one. Any burning questions? Was that helpful? Cool. Feeling good? Do I need to make a whole chapter 9 review video? I hope not. Oh, yeah. Oh, okay. I'll make one. I don't mind. I'll totally make one. I'll probably make one tomorrow or something for you guys. So you'll have a chapter 9 review video where I do them all or whatever. Was this useful? Okay. Next class, what do I want to do? I don't know if we should do 10. I think maybe we should just do everybody works on their final projects in here and you have me as a resource. Does that sound good? I can help you run your hypothesis test for your final project. Does that sound like a good plan? Yeah? Yeah? All right, cool. If you have questions, I'm here. Let me help you. I'll be here early, right? Next Thursday, 5 o'clock, maybe? Okay. Yeah, Thursday? Cool, why don't we do that? I'm gonna double check some things. I may not be able to stay after Thursday, but maybe we could do something tomorrow because I'll be in my office like all day tomorrow. So think about it. Maybe on Zoom or something. Everybody else feels good? Okay, cool. I'll make this video for you guys, the 9 review.